Today we're going to look at 11.6, finding the least common denominator. And so have your book open, have some paper ready. We're going to do the examples that are in the book. And then remember, if you have any questions, you can always ask me. Feel free to pause the video at any time to write things down. Those kinds of things. That's the helpful part of having a video, is that you can do that. All right. So we're going to start out simply here, looking at least common denominator and going back to stuff that we start doing like in 5th grade, 6th grade math, finding a least common denominator. And so I have 3/8 and 5/12. So we're going to follow the practice that is up here so that it helps us when we're doing it with more abstract things. This is a little more concrete. We have numbers, but when we start having variables, it can feel a little bit more confusing. And so we're just going to look at it in its purest form with just numbers first. So my first job is to factor the denominators. So I'm going to do that. So my denominators are 8 and 12. And I want to factor it into with a prime factorization. So that would be 2 times 2 times 2 to get 8. And 12 is 2 times 2 times 3. You're welcome to do, the tree to find those. That's perfectly fine. So these are my factors. So then number 2, I'm supposed to write the least common denominator by finding the product of the factors that show up the greatest number of times in each number. So the greatest number of 2's that show up in either factorization, the greatest number of 2's is 3. Because there are 3 2's in 8. And so that's the greatest number because this one only has 2 2's. So my least common denominator is going to be 2 times 2 times 2 times, so this one doesn't have anything else in it, but the 12 has a 3, and 1 3 is the most 3's that show up. So then I also multiply by 3. So my least common denominator is 24. And I'm not going to finish this one. Well, no, let's go ahead and finish it. We want a common denominator now. So that means I take my original fractions here, and I'm going to multiply them by a fancy 1. Remember, because I'm not changing the fraction, I'm just changing the way it looks. I'm changing the number of pieces that it's cut into, but it's still the same exact amount. So if my least common denominator is 24, what do I multiply by 8 to get 24? 3. So remember, I have to multiply by 3 on the top and bottom. That's my fancy 1. And so I have 9 24ths. And 5/12 I will multiply by 2 over 2. That's my fancy 1, because 12 times 2 is 24. And 5 times 2 is 10. So now these are in the, they have a common denominator. They both have a denominator of 24, and it's the smallest one that we could come up with. So 24 is the smallest number that 8 and 12 both go into. Okay, so we're going to move on to something a little bit more abstract. However, this one, our factoring is a little bit easier because it's basically they're already factored. So remember, we're factoring our denominators. So 5y is 5 times y, okay? And 3ay is 3 times a times y. My least common denominator, 1 5 is the most 5's. 1 3 is the most 3's. 1a is the most a's. And 1y is the most y's. Because remember, we're looking at how many in just individual factorizations. So So in any individual factorization, this one or this one, the most y's that show up in any one of them is 1y. So my least common denominator is 15ay. So that tells me my goal for my new denominators. I want x over 5y to have the denominator of 15ay. And likewise, I want 4 over 3ay to have the denominator 15ay. So, I didn't give myself enough space. So I'm coming up with that 1 that I'm going to put in there to multiply by so that I get 15ay. So 5y, to get 15ay, I need to multiply by 3 to get the 15, and I need to multiply by a to get the a. So now I get 15ay. So that means I need to multiply the top by ay. So I have 3ax. And then over here, I only have to multiply by 5 over 5 because 3 times 5 is 15, and I already have the ay there. So I'm only multiplying by 5 over 5. So then I multiply the top, and I get 20. So now these are changed so that they have a least common denominator. Okay. 11.6c. Remember, you can pause and write this down. I can get it straight. There we go. Sort of. Okay. So remember, my task first is to find the least, or to factor my denominators. So I'm going to factor x squared plus 5x plus 6. And I'm going to factor x squared minus x minus 6. Okay. So I have to multiply to get 6, and I have to add to get 5. And because they're both positive, I know that there's not any, I'm not like going to be thinking about subtraction or anything like that. So it just, what two numbers do I multiply to get 6 that I add to get 5? So that would be 2 and 3. Okay. Now here I have this 6, but I have a negative 6 and I have a negative x. So that means one of my numbers is negative and one is positive. And the larger one is negative because I have a negative x. So the difference between 3 and 2 is 1, but 3 times 2 is 6. So when I factor, I have x minus 3 times x plus 2. I'm hoping these are getting to be fairly quick for you to be figuring out. If they're not, maybe look up something to practice them more, or let me know. Let me know if factoring these is still causing you, like something simple like this. If these are still causing you grief, let me know and I can find some stuff for you or just help you directly. This is very valuable. You will use it some in geometry, but it's really important for Algebra 2. And because of the way that math is, you're going to be skipping a year in between the two subjects. So having this be solid will really help for it to just come back quickly later. Okay, so I need a common denominator now, my least common denominator. So I look here, okay, the most x plus 3's that show up is 1. So I have x plus 3. The most x plus 2's that show up is 1. There's 1 here and there's 1 here. So the most that show up in either one is 1x plus 2. Okay. And then I have 1x minus 3. So that's how I get the least common denominator. I could also put in another x plus 2, and it would be a common denominator, but it wouldn't be the smallest one. And especially when we're dealing with variables, we don't need it to be any more complicated. So this is what we want to stick with, is that least common denominator. Okay, so now I have my least common denominator. Some of the problems you're doing ask you just to find that. So if it was asking you just to find it, then you'd be done and you wouldn't have to do anything else. But for the sake of practice here, we're going to change these numbers up here. so that we have a common denominator. So I have x over, and I am going to write these in factored form. So I have x over, this was x plus 3 times x plus 2. And my other number is 3 over x minus 3 times x plus 2. Now, if my number over here needs to have x plus 3 times x plus 2 times x minus 3 in the denominator, this needs to be my new denominator. Let me focus this. If this needs to be my denominator, then sorry. There we go. If this needs to be my denominator, what I found over here, my least common denominator, x plus 3 times x plus 2 times x minus 3. All I need to do is multiply this by a 1. Remember, I'm still multiplying by a fancy 1, but my 1, I only need to get the factor that's missing here. So for this one, I'm missing the x minus 3. So I do x minus 3 on top and x minus 3 on bottom. And so then over here, I have x times x minus 3. And just leave it. Leave it like this. Leave it in factored form. Don't distribute. Don't do any of that extra work. Just leave it. Okay. And then down here, I'm going to do the same thing. I need x plus 3 times x plus 2 times x minus 3 to be in the denominator. So the thing that's missing is x plus 3. So I'm going to multiply the numerator and the denominator by x plus 3. So I have 3 times x plus 3. Again, leave it factored because the goal of this is so that you can add or subtract. That's why we get common denominators. And if it's factored, I can add this really easily because these are like terms, kind of, in a way. There would be, oh, that's not the right way to put it. But there's an easier way to combine these if I leave them like this for now. So we're not going to worry about that yet because we're not doing any adding and subtracting in this lesson. It's just practicing finding the least common denominator. Okay, and then the last example is 11.6D. And so first job is to factor our denominators. So y squared minus 1, that's a difference of 2 squares. Again, that's something, if you don't recognize those right away, that's something else that you'll want to practice. So I could give you some to practice if you need that. Please let me know. But you want to recognize those because that saves you a lot of work and it keeps you from making mistakes too. So that you're not ignoring this and thinking that it's already factored because it's not. Okay, now these ones are already factored. I can't do anything with y plus 1 or y minus 1. So my least common denominator, using all 3 of the denominators I have, is going to be what? So it'll be y plus 1 times y minus 1. It's going to stay the same as this first one. So that happens. Think about when we're adding, when we're doing fractions, and let's say we have like a half and a sixth and a 12th. The 12 would be your common denominator because 6 goes into it and 2 goes into it. So this would be like that, where this is my common denominator because y plus 1 goes into it and y minus 1 goes into it. So when I change my denominators, I don't have to change the first one. It stays the same. And then my second one, I have y over y plus 1. I need to multiply by y minus 1 over y minus 1. And to get the same denominator for the last one, 3 over y minus 1, I need to multiply by y plus 1 over y plus 1. So now I have 3 times y plus 1. And to make them look the same, I'm going to move these around. Y plus 1 times y minus 1. Because I can multiply in any order I want. So now my 3 fractions, my 3 rational expressions, all have the same denominator. Okay. So in your assignment, you're not necessarily doing all of this work on every problem, so pay attention to the directions, and I believe I included these answers in your other packet, but you want to make sure that you're trying them and doing them first and making sure you understand how the answers are reached. Excuse me. So let me know if you have questions, and I will talk to you in 11.7.